Thank you. Good morning, good afternoon, everybody. Welcome to my session on Azure Data Factory. So this, as hopefully we're expecting, is going to be a level 100 session. It's going to be an introduction to Data Factory. So what I called my slide, I said a complete introduction to Data Factory. Well, for me, that's probably a little bit conflicting in terms because, complete and an introduction, say a little bit conflicting. And probably what may be amusing to you is that I've done lots of talks on Data Factory, but actually trying to do an introduction now to the service is actually probably one of the hardest talks I've had to put together and have put together in the past, because there is now so much content and so many features within Data Factory that trying to figure out what an introduction looks like is quite hard. So with that in mind, what I've done is, if you'll allow me, I've altered my title slightly. So rather than saying a complete introduction, what I've done is I've hopefully distilled this into the key things that I think you need to know about Data Factory if you've never used it before and if you're just getting started. And this is based on my experience of working with the service. But of course, if my perceptions of what I think you need to know is wrong, then do reach out to me. My contact details will be at the end of the slide deck as well. So get in touch if I've missed anything. I'll be happy to fill in any gaps. So let's kick off then with Data Factory then, and let's ask the question of what is Azure Data Factory? And to start, we can have a timeline. So Data Factory actually as a service has been around for about 4 years now, and I've been using it since it was first in public preview back in 2016. And back then, Data Factory was an unhappy service. It was in version 1, and it just emerged and it offered to do some things for us. It was marketed as SSIS in the cloud, but it wasn't. And so there was a bit of a bumpy start for Data Factory in terms of what we could do with it and what it was. Happily though, now in 2020, it is much better. We have version 2 of the service, and as I've already said, it is very feature rich. But again, coming back to that question, what is Data Factory? Well, if we ask the question of Microsoft, if we say to them, what is it? This is the answer we get from their website. And all of these points that we see here are good ones about creating and scheduling our data pipelines and doing ETL, running our SSIS packages in the cloud. These things are all true, but what is the service? Well, the point I like most on this site is orchestrate. Orchestrate our data integration workflows is the kind of the key thing here. So orchestration. So that's the Microsoft version. If I give you my version and we put the question in context of some data that we need to move from A to B to C, whatever, we're loading a data warehouse or whatever the scenario might be, and we say, well, what is Data Factory? For me, it is the umbrella service, that orchestrator that will sit there above all of the things that we want to happen. And Data Factory will allow us to make that possible. It will allow us to schedule that process, to manage it, to monitor it, to look after it, and to define what happens when and what that processing chain looks like. So hopefully that answers the question of what is it. To go a little deeper though, and because we're technical people, we want to know what goes into our Data Factory. So let's now turn our attention to actually the components of Data Factory that we need to build, just to try and inform what the service is and what it's going to do for us. So first component is link services. And I'm going to make lots of comparisons to SSIS because I think it's probably a good starting point for some people. And we say Data Factory firstly needs some link services which will be used to authenticate against our other things, whatever they may be. And that link service will contain maybe the connection string, the username, the password, the credentials, whatever it may be for the service that we're going to connect to. And we can say, yes, this is like our SSIS connection manager. And when I took this screenshot, I think there's about 88 or so link services Data Factory supported. I think we're pushing over 100 now. So as a tool, you know, it really can connect to anything, and it'll give us those link services to do that. So that's component number one. Component number two is this idea of a data set. And the data set will be a metadata representation of the thing we want to work with. So maybe in the case of a SQL DB table, that data set will contain information about the schema, the table name, obviously, the attributes that are in there, the data types, maybe for a file in our data lake, you know, the path that we're going to, the file name, etc. And those data sets will authenticate using our link services in number one. So that's our second component, our data sets. Next up, we have this idea of an activity. So the activity is the thing that we want to go and invoke, and the information about that service that we're going to go and talk to. So if we take the example of a Databricks notebook, if that's what we're going to get our data factory to go and call, that activity contains information about the workspace we're going to hit, the name of the notebook, any libraries that we want, parameters that we might pass to the notebook, and that will all be wrapped up within that activity information. And like with number two, our activities will authenticate with our link services number one. Erland, you're still off mute. Next up, we have this idea of a pipeline. So we could say that everything in our data factory, this is our data pipeline, this is what we're going to go and use, fine in that context. But also a pipeline is a component of our data factory. And what we can do is, with this process, we can logically group things together. So we can say these activities are all going to go into this pipeline, these activities go into this pipeline. And to do some more comparisons with SSIS, we could say a pipeline is a little bit like a sequence container. Fine, that's acceptable, but a better comparison would perhaps be to the action or to execute another SSIS package. And we can do that with an activity in Data Factory. So one pipeline can call another in sort of a parent-child type situation. So those are our pipelines, and for completeness, hopefully we can also say that multiple activities can sit within a pipeline. So that's number four. Then lastly, we have number five, this idea of triggers. So our triggers will attach to our pipeline, and then the triggers will allow us to then go and execute that pipeline. And we can do that in a few different ways. So firstly, and perhaps obviously, we can execute our pipelines manually. If we want, we can go into the developer portal and we can say, trigger my pipeline now, and of course that will go and run. We can use this idea of a tumbling window, which is something that Data Factory v2 inherited from version 1 of the service, which was previously called time slicers. And this works really nicely for our time series data. We can define a timeline, and then we can break that up into intervals of days, weeks, months, whatever. And then we can say each of those intervals becomes one slice, and that one slice will execute our data at that point. And that slice information can be sort of passed down to our data sets, so we can be sure that at a given slice exactly what is going to go and happen. So that was quite nice to say, something that we inherited from V1. Probably the more obvious trigger, and probably the one that I end up using the most, is a scheduled trigger. So very much like our SQL Server Agent, we define a schedule and something will just happen very recursively at the point that we want it to happen, and that will just run and run forever. And like our SQL Agent, you know, we can attach schedules to multiple pipelines or just one, you know, however we want to do that, we have that flexibility. Next up, we have this idea of events from our blob storage. So what our Data Factory can do is it can subscribe to the creation or the deletion of a particular file path. So when that file's created in our blob storage, Data Factory can then go and get the notification of that event, and it will trigger our pipeline. It's basically using Event Grid under the hood, if you're familiar with that service. And then lastly, just to call it out, we can, if we like, from Azure Logic Apps, we do have actions within our Logic App to create and to run a pipeline as well. So we have that option if we want to trigger our pipeline via some external service. Thinking about external things, we can also, if we want, trigger a pipeline with some PowerShell, with a bit of .NET. We've lots of options there. Just food for thought, depending on how you want to do it, but maybe scheduling is perhaps the most obvious. So those are our 5 components of our Data Factory, and depending on what we're doing, we will need probably some of those components to actually put together some process that we want to happen. And all of those components in our Data Factory will use JSON. So if Data Factory is our orchestrator, its hymn sheet is JSON, a loose metaphor. Now, what I want to do is, for this introductory talk, is I want to alter my title again, and what I want to say to you is that for those 5 components, what I'm going to do is I'm going to call them the control flow components. Very much like our SIS packages, these are going to be the control flow things that we need to configure for whatever we're going to do. And what's quite nice is that for the first 4 of those components within our Data Factory, that JSON that goes into them, it can be dynamic. So we can inject into this JSON, we can use expressions, we can make things very flexible in terms of what we configure and what we want to do. And the example I've used here with this code snippet is for a link service. And hopefully, as you can see, it's a SQL instance that I'm going to connect to, and I'm dynamically passing in the instance name, the database, the SQL authentication, the username, the password. So all of these 4 components, the first 4, can have that JSON injected into it. And as you probably expect, or as we're familiar with in our SIS packages, we get a fairly rich expression builder to do that, and we can use this special syntax of an @ symbol, then our curly braces to actually inject into that JSON. And in terms of the actual user interface, what you'll see is when you're clicking around the Data Factory portal, amongst a lot of the property boxes, you'll see this option to add dynamic content. And where that option appears, you'll get the expression builder come up, and then you can start injecting into it with whatever you want. So those are our first 5 components of our Data Factory that I want to tell you about. The next thing that I want to talk to you about is this idea of integration runtimes. So our Data Factory as our orchestrator, it doesn't have really any of its own compute or any of its own storage in that sense. But what it does have is this idea of integration runtimes. And these are, if you like, the bits of compute that Data Factory will use for different activities, for different things that it wants to do. And these integration runtimes, they take 3 different forms. So the first one is, as it's called, the Azure Integration Runtime. And this will be responsible for the calling of our activities. And also, if we're doing a copy of data, it will handle that data movement or that data copy. And what's quite nice about the Azure Integration Runtime is that it can be flexible in terms of the Azure region where it goes. So you could have your orchestration service in, say, the East US Azure region, but you have the Azure Integration Runtime maybe in one of the German regions, if you've got some sort of data regulation problems, or you can't allow the data to leave that region. And that Azure IR in that region will mean that that data does not actually move outside of that Azure region, although it's actually orchestrated perhaps by the service that's in East US. just an example. So that's the first integration runtime to be aware of. Next up, number 2 is an SSIS integration runtime, which hopefully you can guess what that does. It will allow us to run our packages in Azure. And now I'll go into a bit more detail on that one shortly. And then number 3 is what is called the self-hosted integration runtime, or what was previously called the data management gateway in version 1 of Data Factory. And this self-hosted IR will allow us to reach down to our local resources. It will act almost like a VPN client to our Data Factory to allow us to get down to those local resources. Again, I'll talk a little bit more about number 3 in a moment. But let's go into a little bit more detail firstly on number 2, our SSIS integration runtime. And if I said to you, how do we run our SSIS packages in Data Factory? Because we could have invested a lot in our SIS packages on premises. We want to lift and shift them into Azure. We could do that with a virtual machine running SQL Server if we wanted. But if we want to use just PaaS only, platform as a service tech, we could create our package using Visual Studio or whatever. And then in Azure, we will need Data Factory. We can't avoid it. And we will have to create that SSIS integration runtime. Fine. At the point of configuring and setting up that SSIS IR, what you will get is the SSIS DB. So, the core thing that we're probably used to interacting with when we deploy our SIS packages. And that SSIS DB will sit either on a logical instance if we're using the Azure SQL DB service, or we can put it on a managed instance, pretty much wherever you want, to be honest. But that SSIS DB will have to come and accompany that SSIS IR. What we will then do is create a Data Factory pipeline, and within that pipeline, we could use the run package activity. If you want, makes life easy, we could hit the SSIS DB with a bit of T-SQL directly to trigger the package if we want. Again, your choice really. But when we run that pipeline and when we call that activity, what the activity will do is it will take that package and it will have a choice of running it on that SSIS IR. And what I want to tell you here is that IR is not just one machine, it can be a cluster of machines. We can have up to 10 nodes here for that package to run on. We can also have 8 packages running per node. So, we potentially have quite a lot of compute here to run our package. We do get kind of that scale out capability. But when we deploy our package in this scenario, if I'm using the maximum amount of compute, that package that I've created is only going to get an 80th of that compute in this scenario. Now, there's kind of 2 points to this slide. The first is, of course, how we actually get our SIS packages running in Azure using the various components. But the other thing I want to allude to is this idea of scaling out that package, because we may have a scenario whereby we've created a child SIS package that then calls, a parent SIS package that then calls lots of child packages. It's a fairly common pattern. But what I'm saying to you is that if you have that pattern that you've used on premises, fine. If we move over to Azure, that pattern isn't going to work because that parent package will still only get an 80th of that compute. What you will need to do if you move over to the Azure side of things is maybe refactor your packages so the activity within Data Factory becomes the parent, and then we call the children that way, and that's how we'll need to operate. But that run package activity, of course, is only going to call one package, so we will need to think about how we scale out those packages if we do move over to the Data Factory side of things. So just bear that in mind. In theory, we would need 80 of these run package activities to make use of all of that compute. So yeah, just something to bear in mind if you have parent and child packages that you want to lift and shift to Azure. Okay, let's move on. Let's come back to our integration runtimes, and then let's just go a little deeper into our hosted IR. So as I've said, this hosted IR will allow us to get data from our on-premises resources. And what we can do is, with a single one of these, we will have a Windows box that could sit locally or wherever, and we have our data factory, and we say in our data factory, create me one of these hosted IRs. It will give you the link to download the client, or you can just launch it, and it will give you a one-off authentication key that will allow that client to be registered to your data factory. And if you go through the motions and set this thing up, you will get that connection. You will have that hosted IR client that can talk to your data factory. Once you've done that, then you could create a pipeline, and you could get to your local CSV data sets, and you could copy them up into Azure, into your data lake, is one option. We can, if we like, via that hosted IR, access our ODBC drivers. If you've got something special that you need to talk to, you can access your local SQL Server instances. It does kind of give you that sort of that poke through the firewall to get down to your local resources via that client if you want. What you can also do is you can have multiple versions of these hosted IRs, so they will act in a failover and load balancing capability. So you can have multiple nodes registered to a single IR in Data Factory, and it will kind of give you that scale out capability if you have lots of data to bring up, or you've got lots of on-premises resources that you want to make use of. So you can have many hosted IR nodes talking to one data factory. The reverse is also true. You can have multiple data factories using a single hosted IR on premises. So you kind of have that flexibility of one-to-one or one-to-many or whatever you want to set up. So here in the picture, I've got a second data factory that is sharing a link with those hosted IRs from my first data factory. So you have that capability as well. And lastly, what I want to tell you about is if you are using Azure Express Route, if you have that dedicated private connection between your local data center and Azure, and you want to use the host IR, what you actually need to do is what probably seems a little counterintuitive is, but you'll need to put those machines on the Azure side of your network boundary. And then what they can do is they can be connected to your Azure VNet, which will have access to that express route, that private connection. And then you would assume that your local servers, your local resources would be on that same network and can talk then through that express route connection. So say a little counterintuitive, but just something to call out. I've seen lots of scenarios where customers will have and are paying for this very expensive express route connection, but maybe their hosted IRs are still actually on the wrong side of the boundary, which means they're still potentially using a public connection. So just bear that in mind, a few things there with the hosted IR. So quick recap on the first section of things to tell you about. 5 components that go into our data factory to make up that service, and those 3 integration runtimes, different flavors, depending on what you want to do, what you need. By default, you will always get the number 1, the Azure hosted integration runtime. Every data factory will have one of those when you deploy it. Then you can configure the others and change them as you see fit. Okay, moving on. So what I want to tell you about next is some key activities. So activities that I might use every day when I'm working with Data Factory. I said it's difficult to give a complete introduction, but I'm going to talk to you about a few activities that I think it's perhaps worth knowing about if you're new to the service. The first of those is what's called a lookup activity. Now, I do want to be clear here that this is not a lookup in the sense of our data transformation operations. This is not joining to a data set to resolve some surrogate keys when we're loading a warehouse. This is very much a lookup in the sense of a control flow activity. And what I've put in my subtitle here is you'll see that I will typically use a lookup to get some metadata to support my other control flow activities when I'm working with my data factory. And on the input for it, it will take a data set, which could be a whole host of things. If you happen to use the link I've got at the bottom of the slide there, this data set can come from pretty much anywhere in terms of the link services that Data Factory can talk to. And what we'll get is, once that lookup has hit that data set, the output could be a single value, a single row, it could be many values, in which case we'll get an array returned from that lookup. So just to extend that example, we could say that I'm going to hit a SQL database table to return a file list. So that data set will go and get that for me. And then the results on the right-hand side of, a select query from that table will be an array of value in this case, which contains the actual data. And I'll actually use this exact example in my demo shortly. So the lookup activity, I say I will work with this activity quite a lot. Pretty much all of my data factories end up with a lookup activity for some reason or another. Next, I want to break my animations, break my slides. Why am I going backwards? Because I'm pressing the backwards key. What an idiot. Let's go forwards. Next, the ForEach activity. So the ForEach activity, hopefully we're familiar with this kind of looping type scenario, but we can, as I've put in my subtitle, allow Data Factory to scale out here, which could be useful. And our ForEach activity, as you would probably expect, will take in an array. Maybe we provide that array from our lookup activity. And then within our ForEach, we will define the activities for a single iteration. We can access the items from that array using the @item syntax to get to whatever's in that array. So probably nothing too exciting, probably what we expect there in terms of a ForEach. But the reason for calling this out is that the actual behavior of the ForEach activity within Data Factory it's a little special. So we could say that we have some sequential behavior, again, more of what we'd perhaps expect, whereby our ForEach would take in that array and it would just loop over, executing each of the things in there, 1, 2, 3, 4, etc. That's probably the common behavior that we'd expect. But when I say the ForEach activity in Data Factory is special, the reason for that is that the default behavior is actually to take in that array, and it will scale out and it will spawn parallel threads for every single one of those iterations that it needs. So that's quite a nice way to actually scale out the operations of our data factory without doing a whole lot of work in our control flow. And what we'll get is, by default, the ForEach will give us a batch count of up to 20 parallel threads that it will spawn, or we can go up to a maximum of 50 parallel threads if we want to really sort of scale out our activities. So if we kind of come back to that scenario of our SSIS packages that I talked about earlier, we could, in theory, look up all of the SSIS packages we've got deployed from our SSIS DB, pass that off to the ForEach activity, and then we put that run package activity within the ForEach, and then we could scale out our sys package executions that way if we wanted. So a fairly easy pattern to get around that compute versus child packages that we might have. Okay. Let's move on then to the third activity I want to call out for you, and that is the custom activity. And the custom activity is where we can extend our data factory with any custom code that we care to write. And our custom activity on its inputs will need a link service to some Azure Blob Storage and a link service to the Azure Batch service. What we can also optionally provide to the custom activity is other information about our other data sets and our other link services that we may have set up within our data factory. And then what will happen is, if we have this custom code, this thing that we've written that we want to go and run, is that within the custom activity, it will call out to our Azure batch service, and that batch service will give us a compute pool of virtual machines. We can define the size of that pool, and then one node within that compute pool will be one virtual machine. And we can choose our operating system, we can choose our version, we can choose how big, so we can scale up and scale out with that Azure batch service. And that's what the custom activity will use in terms of its compute to go and run. A little bit like our integration runtimes, but a little more tailored to this activity that we're going to call. Then that custom code that we've written, we will have a master copy of that, a compiled copy of that in our Azure storage, which will be used at runtime, and the Data Factory will put an instance of this custom code on each of the nodes in our batch compute pool, and it will also give us that optional JSON reference data as well, and it will pass that over to the batch compute pool, and that JSON will then sit alongside our custom code at runtime. What we then get ultimately is the output from our custom activity is our standard error and our standard out in the form of a set of logs that will go back into our blob storage. We will get the run ID of the data factory as a subfolder within that blob storage, which contains those log files. And then the output from our custom code is, of course, whatever we wanted it to do at the time. So I want to go a little deeper into that and actually just tell you how we would go about building that custom activity. Now, the reason I've included this in my slides is because actually creating this custom activity is still the most popular blog I've got up there on my site. So I'm calling it out because there does seem to be a demand for how we do this. So in my case, if I'm creating this custom thing, I would start with Visual Studio. I would probably write some C# classes, as you prefer, doesn't really matter. And I would compile that to an executable to run on a Windows machine. Of course, go your own way. That executable, I would then put that into some Azure blob storage to become the master copy of that compiled code, or kind of the base version of that code. I would then have my data factory. I would deploy my Azure batch service, and I would configure a compute pool within there, which can, of course, dynamically scale out as well, so you're not wasting any money in infrastructure costs. Then for this scenario, what I'm going to say to you is that I have a data lake over on the right-hand side, which contains some raw CSV data. And for this scenario, I'm going to say that my CSV file has 20 attributes in it. One of those attributes just happens to be a free text field that I've got from my source system. And because it's a free text field, some helpful user has put some carriage returns into that free text field, which has broken the structure of my CSV file, which means a lot of my schema on read things that I want to now use to transform this raw data are probably going to break because that CSV structure is broken. So I'm going to use some custom code, some C# to overcome that. I will then, in my data factory, create a pipeline. I'll create that custom activity, and then I will tell it to run. So like in my previous slide, I said to you that Data Factory will talk to these link services. At runtime, that executable will get copied onto every node within my batch service, within that compute pool. And then that app, that executable will go and run. It will talk to my data lake. It will download that raw data onto its compute node. It will do that transformation work, and then it will put it back to my data lake in the form of a cleaned data set in this case. And as I already said to you in the previous slide as well, the output will be a log file that goes back to my blob storage. Now, just to complete this picture, we also need to think a little bit here about authentication as well. So our custom app, our executable that's running in our batch service, it can't inherit the authentication details from our Data Factory link services. It will need to authenticate against our data lake within its own context. It has to do it itself. And for that, we might need to interact with our Azure Key Vault to do that. So just bear that in mind. So as I say, I've included this slide because it's currently my most popular blog on my site, fine, but also this picture is fairly scary, lots of plumbing here to do. But what I say to you is that if you are familiar with SIS packages, then all of this plumbing, it's really just the same thing as what would happen with a SIS package script component, except within our Visual Studio SIS package, we drag on that script component, we hit edit, we get that temporary Visual Studio environment that's got a lot of the C# boilerplate stuff already in there for us, and then we just have a nice little section that says write your code here. And we will do that, we'll hit OK a few times. That code, that C# will get built for us, and the binary will get inlined at the top of our DTSX, our SIS package file. And of course, that will then go and run as part of the SQL Server suite. Now, in SIS world, all of that plumbing and all of that setup and interaction, it's kind of taken care of for us. We kind of get a friendly, intuitive developer experience to do it. Now, this custom activity that I've got on screen, it's all of the same plumbing. It's just now that we're working within an Azure environment, we're using this PaaS tech, we have to obviously do some of that glue and that sticking together ourselves. So don't be too scared by this picture, just treat it as a SIS script component, except it's an Azure custom Data Factory custom activity. Hopefully that's a reasonable comparison to quell the fear. So quick recap on those things. We talked about our lookup activities, our ForEach activities, and our custom activities. They're the only three that I'm going to kind of talk about for this introduction session. Probably the main three that I might use in most of my data factories. Definitely the ForEach is a good one to consider because of that scale out capability that you get. So with that, let's have a quick demo just to kind of bring some of those things to life. And what I've done is I've included a rough logical sort of architecture of my demo in the slide deck, really just for your reference. But let's go through it and let's take a look. So what I've got is on my laptop, I have a hosted integration runtime already installed and registered to my data factory. I have on my C drive a folder called ADF root, and in there I've got a bunch of CSV files, all very small, all very demo friendly, but in a set of different subfolders on my C drive. So I'm going to use this hosted integration runtime to upload those files. So then if I come into my Azure portal, if I go to my data factory, and if I go to the author and monitoring, which kind of then gives me the data factory portal user interface, and I hit author, and then in my pipelines, I have a demo pipeline that I've called Lookup and upload. Now, this pattern very much alludes to and uses the things I've already talked about in my slide deck. Now, I have, I think, 7 files on my local C drive that I want to upload, but I'm not going to have 7 copy activities to do that. I'm going to use a lookup and a ForEach to do it in parallel. And let's start at the bottom within my ForEach activity, and this is where I've got the copy data activity. And that copy data is going to have a source data set, which is a data set that I've already got set up that is talking to or is using a local file system, and that's using a link service which is connected to that hosted integration runtime that you already saw. So go into my local C drive, but then I've got parameters in here, as you'll see, for the source directory and the actual file name. So then in my sink, I have, or the targets of where this is going to go, I've got another data set, and this data set is going to a data lake gen 2 directory, which I've already got set up. It's going, again, I've parameterized my target directory and my target file name. And in my Azure Storage Explorer, let's just prove there's no cheating and actually delete that content. And we'll do the upload again. So that's just going to some data lake storage. Then if I come to the level above, what I've got firstly is that lookup activity. And that lookup activity is going to hit a table in a SQL database for me. And like my slides, it's going to hit a table called file list. So in my SQL database, I've got some metadata that I can use to support my data factory and actually just to drive this upload. So in this first table at the top, you'll see that source directory, that target directory, and obviously the file name. And then I've got an upload log, which you may have seen within the ForEach. That was calling a store procedure just to, give me some logging information that's actually happened and to write that back to my database. Maybe a common pattern, maybe not, but truncated just to prove there's no cheating. So this metadata, the lookup's going to retrieve it. It's going to return an array. It's going to pass that to my ForEach loop. It's then going to go into that, and it's going to have that copy from my local C drive up into Azure Data Lake. And then what I've done is I've just called an email alert, which is actually using an Azure function underneath just to let me know when that's success or failed. So I'm going to run this in debug mode. We'll talk more about debug mode in a bit. And what we'll get in debug mode via the Data Factory UI is we'll get the output of this pipeline as it goes through those activities. So the lookup has happened, and we can actually look at the output of that lookup. So you'll see that value array and the data that's come from my SQL database table. What you'll then see is that the ForEach is triggered, and those 7 parallel copies, because I have 7 files, they've all spawned in parallel. Let's hit refresh again. Those copies have happened. They've also ran that logger, that store procedure call that I also had in there. So that's all nice green ticks. And then I've got that email alert happening as well. And if I go into my Outlook, you'll see a new alert just come in with some useful details that I've passed to it. So a very simple pipeline, a dynamic pipeline that's using that metadata to get that CSV, those CSV files from my local machine up into Azure. So nice and easy. Let's jump back to the slides. And next, let's talk about Data Factory data flows. Now, what I've said to you so far is that within, oops, wrong screen, sorry. Within our Data Factory, we have this idea of control flow components, using that comparison of SSIS. What I want to now say to you is that we do also have data flow capabilities as well. And in Data Factory, they take 2 different forms. Firstly, a wrangling data flow, and then secondly, mapping data flow. And actually, these data flows form activities that we have within our Data Factory. So firstly, let's take a quick look at some mapping data flows. And what we'll see is if we create one of these within our pipeline, we'll get something via the portal interface that looks a little bit like this. And hopefully, if you're familiar with SIS packages, this does very much look like our SIS package data flow engine as well. We do get this graphical interface where we can add things to it, we can transform our data using the data sets and things that we've been given. Now, the great thing about this data flow capability within Data Factory, the engine that it's actually using underneath to do this is Databricks, or it's using a Spark cluster underneath to actually do that transformation work. So we do get this cloud native tech supporting Data Factory to do the heavy lifting, to do the transformation of our data, which is nice. If we go a little bit deeper into those data flows, we do get some very nice graphical capabilities to set the partitioning and things. We can define that on the fly via the Optimize tab. I'm not going to go too much into the data flows. It's kind of a talk in its own right, but just to kind of give you a flavor of what we get within a Data Factory data flow. These are currently the transformations that exist. And if we're doing some SIS package word translation, we could say, you know, we've got a multicast here as well. We've got a merge join, or they're without the sorting, and maybe a script component. We do as well at the data flow level get a very rich expression builder, so we can set up some very nice things. The regular expression matching is very nice to have as an expression rather than needing script components within a SIS package, so that's quite good. What I've left on my screenshot is this idea of turning on debug mode. So what we do get when we're building our data flow as well is we have this debug option, and if we turn that on, it will warm up a general purpose Databricks cluster for us. And it will mean that every stage in our data transformation, we can preview the data as well. So no more multicasts and data viewers via a SIS package. We do get that sort of very nice debug capability as we build up that transformation, and we can see that, so fairly nice. Then let's just give you a quick intro to a wrangling data flows. Now, our mapping data flows were very much compared to our SIS packages. With our wrangling data flow, we get an interface that looks a little bit like this. And hopefully, if you've ever used Power BI Desktop or even Power Query within Excel, this interface may be familiar to you as well. So within Data Factory, we get this Power Query type environment in the form of a wrangling data flow, if that's our preferred tool to actually do transformations on our data sets that have come in. And like with our mapping data flow, we have a Spark cluster backing up the actual transformation work that's going to happen. I've said in my picture here, maybe it's the JSON of that wrangling data flow that's going to be passed off to Databricks, but more accurately, if we go to the advanced editor, it's the M that we have some Microsoft secret sauce that is converting that language into some compiled jar files that get passed to Databricks. So that was a quick intro to the data flows. The last thing I want to tell you about is configuring that cluster. Where do we actually tell Data Factory what compute we want? Well, this is where I come back to my integration runtimes. And actually, the first of our integration runtimes is where we will tell Data Factory what cluster we want for our data flows to run on. And we can go into the options and we can say what type of cluster do we want, how long is it going to live, how many worker nodes do we want, etc., etc. So it's that Azure integration runtime that you'll use to define your cluster. So just a quick recap on our data flows: mapping, very much like SSIS; wrangling, very much like our Power Query interface; and bear in mind it's the Azure IR where we configure the clusters for both. Last section on my Data Factory intro, let's just think a little bit about DevOps and let's think about our source code. I'm fairly conscious of time, so we'll go through this one quite quickly. We do have to develop Data Factory via the Azure portal. There's no way around it. We can't work on Data Factory via a train or a plane, unfortunately. We do have to go into the portal and use the author and monitor, as you saw in my demo. Now, In my demo as well, you saw an interface that looks like this, but let's just think about the toolbar here in the context of our DevOps scenario and in the context of our source code. Some of it is fairly obvious in terms of the branch that we'll select, and we do with Data Factory get this difference between a debug environment and then the published service for one Data Factory. The other one perhaps to call out on this slide is the save mechanism. So when we're clicking around in our portal and we actually have a dirty pipeline or a dirty panel within the UI, if we hit save, it will do a commit of that pipeline to our repo. So every save will do a commit and a push of that code. If we hit save all on multiple dirty pipelines that we've edited, it will do one commit of all of those changes. So just bear that in mind, obviously very different to how we might interact with some code in Visual Studio. The ARM templates and things I'll allude to, and we can on the top right get to see the JSON behind a given component. We do get that in lots of places in our Data Factory. So just bear those things in mind if you're working with it. What we do also get, as you saw from my demo, is a debug capability which will run the pipeline at the control flow level. And then also, as I alluded to, for our data flows, we do get the ability to warm up that cluster, which will then allow us to either debug, or if we're running the control flow of the data flow component, we will need that turned on as well. What's also quite nice to bear in mind is that at the control flow level, we can set breakpoints on those activities. So you see here, I've set a breakpoint on the ForEach activity, which means everything downstream of it then becomes grayed out. Quite a nice feature if you've got a complex pipeline. Next thing I want to tell you about is source control and the actual JSON behind our Data Factory. So we're good developers, we're working in the portal UI, and we've connected our Data Factory to Git or GitHub, whichever you prefer. And as I've said, that we get a debug environment where we can run that pipeline that we've created, like you saw in my demo. And we do have this idea of a published Data Factory service, which we get from the publish button. And that publish can actually only happen from our master branch or our default branch in our code repo. Now, when we hit publish, you'll notice that Data Factory will create its own dedicated branch within our repository called ADF_publish. We have no choice about that. It just sits there, and that's what it uses to do that deployment from the debugged or the developed JSON to that published service. Now, what may be slightly confusing is that when we hit save, you will get a commit of that JSON to your repo in terms of the folders and the components of Data Factory that go in there. That's quite nice, you do get that. But what could be confusing is that you can then export an ARM template via the UI, which will give you another set of JSON that represents your Data Factory. And just to make things even more confusing, from that ADF publish branch, you will also get a ARM template for factory.json file, which again, you could use. So kind of putting those different flavors of source code in context, if we're talking about deployments, we could say option one, if we have a single Data Factory, not ideal, but we could say that our debug service and our Git connected version of Data Factory is what we're going to use for development, and we're going to hit publish, and then that's going to be our production service if we want. Again, not ideal, but one Data Factory. We could also say that option two, probably more common, we're going to have multiple Data Factory environments, and what you want to use is from that ADF publish branch, the ARM template for factory.json file. That's the artifact you'll want to use via your DevOps release pipeline to deploy those other Data Factory services. There is an option 3 for deploying Data Factory, which I'm not going to go into here, but you can have a chat with my friend Camille about his Data Factory PowerShell module as a third option if you want a bit more control. But these are perhaps the introductory methods that you need to be aware of. So quick recap there, DevOps and debugging, source code, bit confusing, and then a few options for deployment. So just to wrap up then, as I'm 5 minutes over and to come full circle, I said to you in the beginning, what is Data Factory? And I described it as that orchestrator, that umbrella of this thing that we want to happen. If we now just kind of take that knowledge from everything that's in this slide deck, and if we come up with maybe a better picture, a more involved picture based on what we now know about Data Factory, and say, yes, it is actually the orchestrator of our control flow operations. It's also the orchestrator maybe of our data transformations as well via those data flow capabilities. And we could complete it by saying we do have our SQL Agent type scheduler options there via triggers as well. So hopefully that now kind of takes us full circle on what Data Factory is and gives you a bit more to work with and get going. So thank you for listening, folks. The slides, if you want them, you're very welcome in my GitHub repo at the bottom. Mr. Paul Andrew, the same as my blog and my Twitter and email as well. Please do help yourself. Thank you.
Cool, thank you very much, Paul. Lots of a few nice comments, people saying nice things about your presentation, so clearly it's gone well. I've got a few questions for you. The first one, and I do apologize if I mispronounce this. It's from Barani Dharan, and they've said, hi, to read from Excel sheets, we are converting sheets into CSV and loading it into Data Factory to read. Is there a feature in Preview or a better way to read from Excel directly into ADF?
Not at the moment, but I do believe it is on the roadmap. That's something that Microsoft are working on. So support for Excel sheets natively in Data Factory is coming. So cool. Be patient, I guess.
Fantastic. I've got a question from David here. Can you pass a pipeline name as a parameter to execute a pipeline task?
No, you cannot, unfortunately. It's a definite bugbear of mine. So the way I get around that at the moment is, sadly, I call out to an Azure function and get the function to invoke the pipeline, which can then make it dynamic. I have asked Microsoft to make the execute pipeline activity, the pipeline name dynamic, but it's not happened yet. So yeah, unfortunately not.
Okay. Couple more questions. This one, and by the way, if anybody listening has any other questions, or if you're listening to one question, that's
you've got 2 minutes.
You've got 2 minutes. Throw it into the chat window, and I'll throw it into the questions pane, and I'll try and get to it. If we run out of time, we run out of time. From Frederick, is Databricks required to work with pipelines, or maybe recommended, or does Data Factory do the job just as well as Databricks?
Probably a slightly confused question there, maybe, but you will use Databricks for the data flow activities. You don't strictly need Databricks for the control flow things. The control flow things, Data Factory will handle via its own integration runtime. But if you have a Databricks activity, you will of course need a Databricks service there to call out and run that notebook. So probably a few different answers depending on the context there.
Cool. Another quick one from Bilal. Is there a roadmap for reading from Google Sheets?
I don't know. Maybe one to ask Microsoft, I'm afraid. I'm not sure about
that. Okay, from Limor, and this is going to be a flame war question. Can we work with XML? I assume he means instead of JSON.
Via a data flow, I don't think XML is currently supported. I could be wrong. If you've got XML, yeah, you might need to break out something else via a Databricks notebook or do something else with it. Not natively, I don't think.
Related question from Nick. Does Data Factory support XML files? I have lots of load and couldn't see that in the list of sources. I think that's what
Yeah, I mean, if you've got an XML file, you'll have it on some file storage and the link service will talk to that. It's then when you bring it in and you want to start parsing that XML, what do we do it with? So yeah, maybe we might need to have something a bit more custom to do that. Yeah, we really I need to figure out if the data flow will support XML natively at the moment. Yeah, want to find out.
Cool. We've used up all our time. There are a few comments there that say nice things about you, Paul. I don't have time to read them all out, and I don't want to stroke your ego anymore. There was one question about, is your presentation going to be available online? It's there on your final slide. It's on your GitHub page. Thank you very much, Paul. I'm going to hand over at this point to Sander and Alexander.
Thank you, everybody. Bye.
Bye, folks.